Well, hello, all y'all. I'm Dr. Barbie, a cousin of your teacher, Mrs. Jackman, and I'm here today to give you a little lowdown on nutrition and help you fill out your packet for Chapter 14. We're going to start towards the end where we talk about the effect of the biological molecules that come from the foods that you eat on your overall health and well-being, paying particular attention to metabolism and body temperature regulation. So, back in the day, in the 1990s, our government started caring about whether or not we were healthy eaters, and they developed some different guidelines to help us be healthier Americans. When I was growing up, and when your teacher, Mrs. Jackman, was growing up, we used to see this little pyramid on the side of our cereal boxes while we were eating our Frosted Flakes and Cheerios. And it was telling folks that they should eat mostly grains and breads and cereals, and then have a lot of fruits and veggies that were fresh or canned back in the day, and limit the amounts of meats and dairies. We didn't need as many of those, and definitely limit the amount of fats and oils and sweets. That was kind of an antiquated way of telling us what to eat, though, and a lot of folks were getting obese back in those days. So the pyramid was revised to be, they kind of took the same categories and just made them into vertical wedges. This is grains and fruit, vegetables and fruits and oils and proteins and dairy, or that's dairy and that's proteins. And they added this little staircase along the side of the pyramid because so many Americans were getting fat. They're like, just you need to get out, get off your ass and start exercising. So they added this component to the pyramid. A lot of folks still didn't like this pyramid. They said this is confusing, these different size wedges. It's not helping Americans be healthier. And so then Obama, actually it was Michelle Obama, helped revise nutrition in schools and had gardens get put in the White House lawn. And she worked the Surgeon General at the time to develop this plate called choosemyplate.gov. Some folks still don't like this set of guidelines. They feel like the dairy industry has been lobbying too much with the government to get to include that little glass of milk over there. But it's what we have to work with right now. So you children are going, well, no, you're not children. You're young adults. You young adults are going to be doing a project to investigate the biological molecules that you might find in each of these different areas of the recommended portions that a person your age should eat each day. Because a lot of the things that we read about are like, you need to be healthy. You need to make healthy choices. But who really knows what healthy is and why? So that's what I hope you're going to learn. Chapter 14 is going to discuss what happens to each of those types of biological molecules. The carbohydrates that you eat need to be broken down into their tiniest size in order to be absorbed into your bloodstream and be available for your cells to use. The primary reason you're eating all those carbohydrates is to give your cells energy in the form of ATP that you can use for anything your body wants, being warm, building new molecules, helping you move, helping your cells push things against the concentration gradient and get them to where they need to be. The lipids that you eat are primarily to be formed into cell membranes and certain body parts that you have that are made of lipids, but they can also be combusted by a mitochondrion and give you energy. In fact, they're a super concentrated source of energy. They also insulate your body and protect organs. That's one of the functions they have. The proteins that you eat are primarily used as amino acids to build new parts of you. They're divided into the functional proteins that are things like enzymes and antibodies and hormones, and the structural proteins that make things like your hair, your skin, your muscles, your collagen that fluffs up your skin so nicely. And most of you really is made of proteins. Um, Amino acids can also be combusted by the mitochondrion and used to provide you with ATP energy. So all these things give you calories, which is a form of measuring energy. And if you consume too much of any of them, you're going to have too many calories and your body's going to have to cope with that. When your cellular respiration occurs, your mitochondrion is the powerhouse that's able to take amino acids, fatty acids, or glucose, breaks down into pyruvic acid, and combust it into ATP. In the absence of oxygen, your cells can still do the process called glycolysis and get a little bit of energy out of each glucose. But in the presence of oxygen, this mitochondrion can do these two other processes and make a lot more ATP energy out of each glucose. This is kind of a complicated looking little diagram, but I put it here because I wanted to let you know that when your body uses proteins or fats as a source of energy instead of carbohydrates, there are some waste products that are formed. One of them is called ketones, and it can give you a condition called ketosis, which makes your blood more acidic and can screw up a lot of the shapes of your enzymes and make you get very sick. So, going on a diet to lose weight that avoids carbohydrates and relies on proteins and fats, which has been kind of a popular diet in our country different times, isn't a very healthy thing to do for a very long-term time. So you shouldn't do it without doctors kind of monitoring your bloodstream, making sure you're not getting ketosis. Your liver plays a big role in metabolism and monitoring your bloodstream levels. You learned about your pancreas making insulin and glucagon a while back, but your liver can also monitor glucose levels. When you have too much, it takes the extra glucose out of your bloodstream and stores it as glycogen, a polysaccharide. Can't store very much though. And then when your blood sugar levels are low, it can release that glycogen and break it apart into little glucoses and give you a little energy when you're hungry. It also filters out your blood and it looks for toxic things like poisons, like drugs and alcohol. Drugs, even prescription drugs like Tylenol, need to get out of your bloodstream eventually, and your liver is the place where it happens. So it has a lot of enzymes, a lot of detoxifying enzymes to get rid of bad things, including bacteria. So it's working hard. It's like the filter of your body to get rid of all the junk, which makes you kind of wonder about eating it. Kind of like eating an old dirty filter, but it's very high in vitamin A because it does synthesize a lot of things as well. It synthesizes bile. Bile is kind of a strong chemical that's able to emulsify fats. That means it breaks big fat bubbles into small fat bubbles and makes them easier for your enzymes to get to and digest when they're in your small intestine. It also synthesizes a molecule called cholesterol, which we're going to talk about a little later. Ooh. Luckily, this filter has the capacity to repair itself. So when people abuse their liver by giving it too many drugs and too much alcohol to filter out, it'll fix itself for a while. Eventually, though, if you abuse it for a long time, it'll get fatty and enlarged, and then it'll start getting scar tissue and it'll get hardened. And a person who's had like a lifelong alcohol problem will get a condition called cirrhosis, where their liver stops functioning. Without a filter to take all this stuff out, you just poison yourself and die. Glycogenesis and glycogenolysis are the two processes of your liver making glycogen. That's what genesis is, a word that means making things, or breaking glycogen apart to give you more glucose. Lysis is a suffix that always means breaking things apart. So, some folks have heard about cholesterol before, and mostly people think it's all bad, but turns out cholesterol is an important component of our cell membranes. Animal cells don't have a cell wall around them, and they're super flexible, and cholesterol embedded in the cell membrane helps give them a little level of rigidity and helps them hold their shape. Cholesterol also is the structural basis of many hormones and vitamin D. So it has some positive roles within it. Your LDLs and HDLs are sometimes people have heard about if somebody in their family has high blood pressure or atherosclerosis, because you can get a condition of high blood pressure or atherosclerosis, which is when your arteries are less flexible, and so they don't bulge out when blood flows through them, but they stay small and make your blood pressure higher. If you have too much cholesterol, it can accumulate in your blood vessels and make them less flexible. So, the HDLs, which stands for high density lipoproteins, are sometimes considered the good cholesterol because they take excess cholesterol out of your bloodstream and bring it to your liver where it can be detoxified and removed from your body. The LDLs are the types of cholesterols that carry cholesterol to your cells for synthesizing things. And if you have too much cholesterol, then they end up just placing it inside your arteries and giving you conditions like atherosclerosis. They're both necessary. They're not really good or bad, but the LDLs get the bad reputation. So if somebody in your family has high blood pressure or high cholesterol, they might be put on a diet of food that doesn't have any cholesterol in it. Only animal food has cholesterol in it. So one of the benefits of being vegan is to not add more cholesterol. About 15% of your cholesterol comes from the food you eat, and the other 85% comes from your liver synthesizing it itself. So even if you eat none, you could still have high cholesterol. That's why some medications have been formed that will attach to the LDLs and help get rid of them and reduce your cholesterol to a reasonable level that hopefully won't lead to you having atherosclerosis and high blood pressure. So unhealthy foods tend to be things that might have a lot of cholesterol in them. Another reason why people think things are unhealthy is if they have too many calories in them. In a simple world, the calorie from the foods you consumed, which, that's energy, has to be equal to the calorie of the food, of the things that you do with it, like generating heat or moving things, or if you have leftovers, it's going to be stored as growth or fat. If you're growing, that's great. But if you're not growing, then you're just going to get fat. And that is actually associated with a lot of unhealthy things like high blood pressure, increased chances of heart attack and stroke. Hypertension is another name for high blood pressure. It's actually not that simple though. You don't just lose weight if you have less energy intake than total energy output, gain weight if you have more energy intake than total energy output, and maintain a stable weight if you have equal energy output and energy input. And that's because there are a lot of other factors that might affect how your body's using that energy, and that's called your metabolic rate. In the United States, a lot of Americans are obese. And this is why the Surgeon General started making those little plates and pyramids to try to tell us how to eat better. The amount of obesity has been completely linked with the amount of type 2 diabetes, which really messes up your homeostasis in your body and makes you much more vulnerable to conditions like the COVID virus and heart attacks and high blood pressure and poor circulation and having to have your toes amputated or maybe even your legs amputated, something you want to try to avoid. It's been increasing in the United States. I'm kind of just leaping into another topic on this side. Your basal metabolic rate is considered the amount of energy that you need just for your cells to stay alive, even without you running around and using your energy for exercise. You can change your basal metabolic rate with your metabolic rate. If you have a high metabolism, you're using more calories just to sleep than someone who has a low metabolism. And that's why that whole energy input, energy output thing isn't really fair. Sometimes stress hormones or other hormones can affect your metabolic rate. Anxiety can affect your metabolic rate. Aging cells can affect your metabolic rate. Exercise can affect your metabolic rate. Let's go back for a minute. So if you have a slow metabolic rate and you start exercising, you will increase your basal metabolic rate and be able to eat more without gaining weight. I think everybody knows someone, they're like, oh, I don't eat anything, but I keep gaining weight. They may just have a slow metabolic rate. They could change it by exercising more and by losing weight, but it's hard to exercise more and lose weight when you have a slow metabolic rate and you're overweight. So it's not an easy road to hoe. And that's why weight loss programs are pretty complex, and they deal with a lot of changing your lifestyle, changing how you eat, changing when you eat, changing your mood, because that will affect the hormones in you that are helping to control your metabolic rate. A lot of that is also hereditary. Heat production. When you have a fast metabolic rate, you increase the amount of heat that you're expending and that radiates out of you. If you're really cold and you're shivering, that takes a lot of energy as well. And then hormones can affect your heat production. If you are not able to maintain homeostasis of your body temperature, you can have different conditions. If your body temperature is getting hotter and you no longer have the homeostatic methods to maintain a normal blood pressure, you can get a condition called heat exhaustion and heat stroke, which will make you dizzy and you'll stop functioning really well. Vigorous physical activity can lead to dehydration. I had a bad case of dehydration when I tried to rake all the leaves the other day on one of those crazy hot days, and had to go in the shower and just sit in the cold water until my head stopped pounding and I stopped feeling like I was going to throw up. The opposite condition is called hypothermia. I know you guys have talked about hyperthermia and the prefix hypo and hyper with your teacher. So these thermia mean temperature, hypo meaning low or less, hyper meaning more or higher. Those words kind of tell you what these conditions mean. This condition occurs when your body no longer has the capacity to maintain homeostasis of temperature, and you're just going to keep getting colder till you shut down and die unless you get an external source of heat on you, kind of like a lizard. So usually somebody will feed you some hot tea or soup, or somebody will come and snuggle up and share some of their body heat with you to help you survive and not die from hypothermia. Oh, that's where I'm going to stop. Let me go back. It was great meeting all y'all. I hope you have fun researching the different parts of the plate recommendation from Michelle Obama's administration and the Surgeon General that apparently Donald Trump doesn't know exists because he hasn't gotten rid of it yet. Have fun all y'all. Bye.